Welcome to this 8th episode in our series of video clips explaining the use of ABES geometry control software. In this installment, we will revisit our axis and introduce the concept of axis parameters. For this purpose, we will review our axis definitions, and we will use this tab here on the right side that says axis parameters. Axis parameters are values that change as a function of the station. They change along the axis depending on where they sit along the axis. Let's introduce a new axis parameter by appending a new parameter to this as of yet empty list in this dialog. Right click, append, and we will name this new parameter CF. This empty table will tell the program what value this new parameter will take on depending on the station of the axis. We insert 3 rows. At station 0 we want CF to take a value of 1%. At station 100, and that's the peer station, we want a value of 2.5%, and then 100 meters further along the axis we want CF to go back to 1%. We can accept this data now, and it will be available in the database for further use. Let's use this axis parameter next, and let's revisit our cross-section for this purpose. In this cross-section we have already introduced a parameter, a local parameter called CF, and this local parameter has modeled our crossfall. This is a fairly radical crossfall here, and by no means a practical value of 10%. But by using 10% we have made it very visible in our diagram that I just showed. In any case, I am going to change this CF parameter from a local parameter to an SOL dependent parameters here in this dialog. CF, I am going to give this a default value just for visualization purposes, and in case the program needs it otherwise, of 10% again. However, upon accepting, we are made aware of the fact that this is now an ambiguous definition, and we need to delete the local definition in favor of the SOL dependent definition. Error message has gone away, and we are now looking at a cross-section with an SOL dependent parameter, and what that means is once this cross-section is used in a segment and further on in a segment group and placed on an axis, the program will look to the axis definition and see whether there is a CF parameter on that axis, and if that is the case, CF will be taken from the axis definition and not from the default value here. If it cannot find the CF with the axis, then the default becomes the value of choice. Now, if we look at the visualization of our bridge, it's a bit hard to detect that transition from 1% to 2.5% and back to 1%, and you'd have to take my word for it that this has actually worked. However, we can make another instance of an SOL dependent parameter that will be a lot better to see in the visualization. For this purpose, I go back to the axis parameters, and I will introduce yet another SOL dependent parameter, and I call it depth. It will be the cross-section depth. In fact, I'm inserting 5 lines in this case, and the depth should be 3 meters starting at the very beginning of the axis, and it should remain 3 meters up to station 95, but then increase to 5 meters at the pier station, go back to 3 meters 5 meters later, and remain at 3 meters for the remainder of this list. Accept, and depth is now available as a station dependent variable parameter for further use. So we are back now in our cross-section definition, and I'm going to replace coordinates for points 6 and 7, which are the two bottom points of the cross-section. The -3 here, the hardwired value, will become minus depth, and that's already our first example where we use an arithmetic. The minus here is actually an arithmetic expression instead of just a number or a parameter. Minus depth. So the coordinates for point 6 and point 7, when we compute the z coordinate, we will use the value that depth has. And of course we must tell the program that depth is an SOL dependent variable. We introduce it here, depth. We give it a default value so it can be drawn even without an axis associated. Resolve and accept. So our cross section has now a station dependent crossfall and a station dependent depth. If we look at our bridge again, we can see how that has played out. We now have a 3 meter cross section depth up to this location here, and we have a change, an increase to 5 meters at the pier station. Again, one can discuss the practical usefulness of what we've just shown, but I think it's becoming obvious that axis parameters can be used in many different ways, and cross sections can be made into macros adapting their shape and their properties according to wherever they are placed along an axis. This is very useful, and it can streamline a model in many ways, and I can only encourage users to make good use of this particular feature of ABES geoDes.